Hello, I am going to briefly present our ResearchLines sustainable chemical processes based on unmobilized molecular catalysts. My name is Francisco José Fernández Álvarez, and my research is focused on the green chemistry of sustainable catalysis. Our main objective is the transformation of anthropogenic waste into useful materials. For instance, you can see here in this slide how we have been able to transform carbon dioxide just using hydroxyloxanes, which are residues from the silicon industry, into useful molecules. We do this, we design transition metal complexes that can be used as catalysts for accelerate this type of reaction. Why this research is important? First, using a catalyst, you reduce the activation energy. Therefore, you will need less energy and you are saving energy. Moreover, the catalytic processes, they have usually a great atomic economy. Therefore, you are also saving, reducing the amount of waste. Moreover, our project is focused on transforming waste into products of chemical interest. Therefore, we are also recycling. We have been really successful developing several catalytic processes. However, our next step is to apply it to the industry. Therefore, we would like to design catalysts based on abundant and inexpensive transition metals and to develop supportive catalysts based on homogeneous catalysts in order to be able to use it in an industrial scale. That is all. Therefore, we are waiting for you.
Hi everyone, thank you for your interest in our research. The Organic Photochemistry Research Group in Universidad de La Rioja is interested in the interaction between light and matter in three main research lines: photoprotection, photoswitches, and energy storage. We try to go all the way from the basic research to the final application. So, for instance, we have several patents and contracts with companies. This project is focused mainly on energy storage, a research line in which we have been quite active in the last years, and now we are part of a quite ambitious European project. The idea is to use the so-called molecular solar thermal systems, which are based on a photochemical reaction in which we use the sunlight to turn a parent molecule into a high-energy isomer. And in doing so, we can store part of the solar energy into chemical energy. This stored energy can be released through a catalytic back reaction when needed. Using these very basic design principles, a working device was built with excellent performance regarding the heat release. Within the European project, we are now trying to build or design and then build a new device, trying to take advantage of both light and heat coming from the sun. Our participation in this project is mainly focused on the catalytic heat release device. This is a truly multidisciplinary topic in which we use organic synthesis, photochemistry, catalysis, and computational chemistry. So anyone with a background in one or several of these fields would be welcome. We have contact with many different research groups and companies worldwide, so we can offer a truly exciting project and experience. Thank you.
Buenas tardes, soy Antonio Gil, profesor y responsable del Grupo de Investigación, Tecnologías y Aplicaciones Medioambientales de la Universidad Pública de Navarra, y a continuación les voy a detallar la temática en la que estamos trabajando, investigando y desarrollando líneas de investigación. En concreto, llevamos una serie de años trabajando en lo que es la valorización de residuos industriales y en concreto en el caso del reciclaje aluminio, donde a partir de una materia prima, tras fundición, se obtiene el lingote que se comercializa, pero al mismo tiempo se obtiene un residuo que es una escoria salina de aluminio que está clasificado como una escoria, un residuo peligroso. En el proceso Hansen, que se detalla en esta diapositiva, partiendo de la escoria salina de aluminio, se obtiene posteriormente un residuo adicional que está tratando de valorizarse. Nuestra idea es, a partir de este residuo peligroso, tratar de obtener otros materiales que puedan ser aplicados, sobre todo desde el punto de vista medioambiental. Hidrotalcitas, celulitas, isoaluminatos, arcillas pilareadas, siendo la idea la extracción del aluminio que contiene este residuo de las escorias harinas de aluminio. Aplicaciones como absorbentes de contaminantes emergentes, aplicaciones como fotocatalizadores para la eliminación de estos contaminantes emergentes, todo basado en óxidos de titanio incorporados o soportados en estos materiales, y también la valorización de CO2, en concreto, en el caso que les presento, es el reformado seco de metano, donde utilizamos catalizadores basados en níquel como fase activa metálica y exaluminatos, dado que presentan una resistencia a alta temperatura. Todas estas líneas, partiendo de un residuo peligroso, se entrarían dentro de lo que es la economía circular, muy de moda actualmente. Para cualquier cuestión, aquí les dejo mis datos de contacto, que en cualquier momento pueden contactar y preguntar por más datos de este proyecto. Gracias.
This topic deals with the inspection of solar cells using terahertz frequencies. This belongs to the research line of energy. However, it is mostly linked with the use of information and communication technologies for this application. The idea is that solar cells, photovoltaic technology, has suffered a huge evolution during the last years. However, there is still a remaining issue that needs to be addressed, that is the durability and reliability of these cells. This is mostly linked with the polymeric material that is used for encapsulation. These are materials that are prone to aging and then tend to reduce the durability of the cells. Current techniques that are used for its inspection are destructive, so we want to develop novel inspection techniques that will be ideally non-destructive, inline, and they will be based on novel ideas and configuration based on metamaterials and terahertz frequencies. This is something that has already been considered as a groundbreaking idea within the Navarra government's Science Acacia Awards. This activity will be carried out within the antenna group of UTNA. We are a leading group in different areas of applied electromagnetics, and we are cooperating with different industrial, academic, and non-academic partners. And in some cases in the framework of European projects, such as those quoted here. And in particular in this line, we will have a close cooperation with the National Center of Renewable Energies and with the University of Siegen. If you need more information, you can have a look at our website, or you can directly write me.
Hello, good morning to everybody. My name is Cesar Fernandez from University of Lleida, and thanks for this opportunity to introduce the research group on energy and artificial intelligence. GREIA is a mid-sized research group with 12 faculty members and several experimental facilities, coming from two different knowledge areas, one from energy engineering and the other one from computer science. Our main focus in research is to develop innovative energy solutions based on hybrid thermal electrical systems in order to reduce greenhouse emissions, particularly working on intelligent control systems based on AI techniques. To our understanding, this research fits into the main objectives of the European Union in order to boost the development of more efficient energy systems, being one of the most growing areas in terms of funding. As a research group, we have worked in AI since many years ago, and we have a great experience in applying smart techniques to engineering problems. Well, I think that's all. Thanks for your attention, and please don't hesitate to contact me to this address for any further comment. Thank you.
I am going to present you our research line in energy sustainability developed at the University of Lleida. We do this within the research group on energy and artificial intelligence area, where thermal energy storage and energy efficiency are two of our main goals. We do work, for example, at materials level. Here, phase change materials are very important, and we can do that either at the bulk, doping the materials to improve the thermophysical properties of those, or in the encapsulation of the materials. Why is important this research line? Well, phase change materials are those that are able to store a lot of energy when changing their phase. So that's it, when going from solid to liquid. And by doing that, they do it at a constant temperature. So this allows us to use them in many applications, for example, in buildings to improve the thermal comfort, but also in industrial applications. We do this by cooperating also with the non-academic sector. For example, with the company ITES, located in Torino, in Italy. They work in the field of energy efficiency by developing and installing several energy systems, and with the aim always to decrease the energy consumption and therefore to participate actively in the energy transition that we are facing. When we help them by using phase change materials, we do that by developing and characterization products, by also developing the systems, and also bringing these products to the industry. Finally, I need to thank all the funding that allows us to do our research, and to you for being interested in our research.
Hello, my name is Jonas Oliva and I work at the University of Lleida. My research focuses on forest pathogens and other tree-associated microorganisms, and we are trying to understand how global change is changing their behavior. The reason why we focus on forest pathogens is because in the last decades we have seen that the forest condition is worsening. We really don't understand why, but we are worried because forests are the cornerstone of a sustainable development as a society. Forests are giving us for free many nice things like wood, biodiversity, recreation, and many other goods and services. And if they are sick, they will stop doing so. We don't understand why, but we have some ideas, and perhaps the main hypothesis is that the trees are getting sick because of climate change. Climate is getting more harsh, increasing temperatures, lower rainfall, and this is making the trees are more stressed. But also it's allowing pathogens to survive and to grow in places that before they could not do. We also have globalization. We are trading a lot with distant places in the world, and this is bringing us new exotic pathogens, and these pathogens the trees here are not adapted to. And finally, all these changes are happening along with a historical change in the way we use forests. Before, we used to extract many more products, and nowadays management has decreased. This creates the forests are nowadays denser, and trees are competing more between themselves. This is making that they are more stressed and susceptible to pathogens, but also these dense forests are better conditions for pathogens to grow and infect other trees. Thank you.
Hello, I would like to discuss a little bit our research group and the main lines of research that we are currently undertaking. So we are a group composed from people from the University of Zaragoza, the Hospital Servet, and the ITA. And we focus on the development of new methodologies for trace elemental and isotopic analysis. We have many years of expertise with a number of atomic techniques based mostly on atomic absorption or ICP-MS. And we have a current focus on biomedical application and on analysis. I don't have the time to discuss everything that we do, so I will focus on one particular example. It's minimally invasive analysis using what is called as dry blood spots. This is related with blood sampling. We all know what venipuncture looks like and advantages and disadvantages. But alternative has been explored for many years, and perhaps the most successful one consists of depositing a few droplets of blab onto filter paper. This is very interesting, not only for children, but also because this material is quite stable. You don't need refrigerators, and also enables to develop home collection schemes. And this is something we are particularly interested. We believe that this scheme of preparing your own sample and sending to the lab could be appropriate in a variety of situations where elemental and isotopic analysis is key. We're talking about screening of toxic metals. We're talking about early detection of some diseases associated with the levels of metals, or we are talking about monitoring of chronic patients. And basically what we do is to test new specimens to produce the DBS with a known volume, easy to use for the patient, and then we develop the methodologies for the analysis. If you are interested, we have more information in this website, or you can contact me for further discussion.
Hello, my name is Marta Haro, and I would like to talk about our project proposal, New Strategies for Energy Conversion and Storage. My background is in electrochemical energy storage and solar to chemical energy conversion. I work at INMA, Instituto de Nanociencia y Materiales de Aragón, together with my colleague Emilio Juárez, expert in photovoltaic energy conversion, particularly with halide perovskite materials. We both collaborate with Isaac Herraiz, technical coordinator at Lomartov, expert in clean energy and sustainable energy solutions and evaluation of environmental impacts. Our research interests are in energy storage, mainly supercapacitors and lithium batteries, and energy conversion, particularly solar cells. We also are interested in studying new strategies for converting and storing the solar energy in electrochemical energy. Our research covers from material preparation and characterization in thin films and device fabrication and characterization. Beyond the research work, we also offer access to collaborate in networks linked to clean and sustainable energy solutions, skills in evaluation of environmental impacts related to energy conversion and storage, international mobility, and the possibility to apply or participate in European projects. For further information, don't hesitate to contact me or any of my colleagues.
We are Maria Bernachea and Jesus Beringer, supervisors of this project. We also collaborate with Julio Gómez, CEO of the company Avanzare. This project combines the expertise of 3 different entities, which are located in 2 different Spanish regions, Aragon and La Rioja, but the distance between them is just 2 hours by car, bus, or train. NFP Group is expert in the development of nanomaterials and nanostructured thin films for different purposes, among them photoactive materials for energy and environmental applications.
Madmore Research focuses on the synthesis of emissive organometallic molecular materials and hybrid photoactive material for their use in photocatalytic lining or energy harvesting applications. Avanzare is the first European graphene producer and is devoted to develop high-performance solutions based on nanotechnology for their customers. The proposed research line focuses in the development of photoactive nanomaterials for photocatalytic applications.
Photocatalytic processes employ materials absorbing only in the ultraviolet. However, the ideal photocatalyst should be able to absorb a wider range of wavelengths to make use of a larger portion of the solar spectrum. The absorbed energy can then be used for different processes, such as pollutant removal or the synthesis of new products.
For the development of the project, we offer our skills and laboratory facilities, and also advanced characterization techniques and evaluation of the photocatalytic performance of the developed materials. If you have any further question or you want to clarify any point, don't hesitate in contacting us. Thank you.
Hello, this is our research line thin film membranes for molecular separations. We belong to the Instituto de Nanociencia y Materiales de Aragón, INMA, from the CSIC, Universidad de Zaragoza. We are Patricia Borgojo, Jonas Gurauskis, and Joaquin Coronas. And we are working on two main membrane working lines. One is devoted to gas separation, and our goal in this case is for a given polymer, for instance, in this case, PVAX polymers, to improve the limitation that, in this case, for instance, there is in the carbon dioxide nitrogen selectivity. Our goal is to reach this region in which we improve both parameters, the selectivity and the permeability. In case of liquid phase application, we prepare thin film nanocomposite membranes for application. These membranes are usually prepared by liquid phase interfacial polymerization following the reaction, but we have modified the implementation of the monomer TMC from the vapor phase. So this supposes the removal of organic solvents, and the membranes prepared from the point of view of physical properties are very similar, but we are able to improve the water permeance of these membranes as compared to the typical membrane. So our goals and challenges are to obtain these thin film nanocomposite membranes, in particular based on metal organic frameworks, to develop green synthesis methodologies, and to improve the separation properties, thinking of carbon dioxide capture and filtration of micropollutants, and of course to think of the transference from the lab to pilot the scale. In summary, just to obtain membranes for greener technologies. Thanks.
Hi, we are Emilio Juarez and Maria Bernechea, supervisors of this project.
Emilio is a leading expert in perovskite materials for solar cells and the study of the performance fading mechanisms.
Maria is interested in the development of nanosemiconductors for use in clean processes and clean energy devices.
We collaborate with Alejandro Del Amo, CEO of Abora Solar, a company located here in Aragon that manufactures hybrid solar panels.
The proposed project fits in the areas of materials science and technology, and more precisely in materials for energy and environment. It focuses in the development of nanomaterials for energy harvesting, mainly for emerging photovoltaics like a perovskite or quantum dot solar cell.
This research line is important because of the necessity of developing renewable energies in the fight against climate change. These energy sources are more environmentally friendly because they don't emit greenhouse gases or generate radioactive waste during operation.
One of the problems of perovskite-based emerging photovoltaics is that they suffer from poor stability. For this project, we will be especially interested in proposal combining perovskite and nanosemiconductors, absorbing in the infrared region of the solar spectrum, with the main goal of improving performance and stability.
For the development of the project, we offer our expertise in emerging solar cells, standard laboratory facilities, advanced nanomaterial synthesis facilities, and characterization techniques. We have access to the laboratory of advanced microscopy. Moreover, we have equipment to characterize solar cells, namely current voltage curves and EQE measurements up to the infrared. If you have further questions or you want to clarify any point, don't hesitate in contacting us.